Alright, AMP1 students, in this video we are going to talk about specific synovial joints in the body. So on our objectives, we are going to start talking about the temporal mandibular joint. So that's our first two objectives here, and then we'll move on and start talking about other joints as well. So what I'd like you to know about the temporal mandibular joint is that we want to know like where this joint is located, so kind of and what its anatomy is. So you would want to know that this joint is formed by that mandibular fossa that is part of the temporal bone. So that's kind of why they have this term temporal in the name of this joint. And so that mandibular fossa in the temporal bone is going to have the condylar process of the mandible. That part is going to connect to that mandibular fossa of the temporal bone. So that's why mandibular is also part of this naming of this joint, because it's the condylar process of the mandible that's forming a joint with the mandibular fossa of the temporal bone. So if you can recall, might be a little hard to see that you have the ligaments around there, but we're talking about that joint right there. So they call it the temporal mandibular joint, again because they're talking about the temporal bone is a surface marking on the temporal bone, the mandibular fossa is part of this joint, and then the condylar process of the mandible is the other part that makes up this joint. So now they will abbreviate this and just call it the TMJ joint. So you'll hear that a lot, TMJ joint, but that's what it stands for. So that is what is forming this joint, is those two structures of the bones. And this specific information that you want to know about this joint is, of all the joints that are in our skull, this is the only one that moves. So in lab you'll talk about other classes of joints that don't move, and that's primarily the joints that are in our skull. But this is the one joint in our skull that actually is mobile. It does move. And again, it's a synovial joint, so it's freely mobile. All right. So the next thing that you want to be familiar with is that it has quite a bit of movement. And you guys can probably do some of these movements as we're talking about them. But one definitely is the elevation and depression movement. So that usually happens when we're talking or when we're eating something. But we can also protract and retract. That when we're with that joint, we can cause that movement of our mandible where it protracts and retracts. So that's just kind of where the mandible moves forward and moves backwards. So we can do that too. And then we have like the side-to-side movements too. We're also able to move the mandible side to side as well. So the things that allow it to be kind of freely movable, it has a real loose articular capsule. Remember, the articular capsule is that structure that all synovial joints have that's made up of the fibrous component and the synovial membrane. So that's more loose, and so that allows it to have more of those movements. And it also has like a little, it's a fibrocartilage pad. They call it an articular disc. So there's actually like a little articular disc that sits in the mandibular fossa, kind of between the condylar process, the head of the condylar process here, and then the mandibular fossa. So it has that little articular disc, and so that's there because we do have a lot of movement going on in that joint, so that provides a little bit more cushioning for the structures associated with that joint. So, all right, now you're not required to know the ligaments that, the specific ligaments that make up the joint, so we're not going to talk about those. All right. So that was our anatomical features of the TMJ joint, and then the movements of the TMJ joint. So the next few, and I'll kind of spread these out. So the next few that we're going to talk about are the regarding the shoulder joint. So our shoulder joint, we have a nice little picture of it here. It's actually made up of three separate joints, which when you say shoulder joint, everybody kind of just thinks there's just like one joint there, but there's actually like 3 different joints, 3 different areas where bones are communicating with each other and connecting with each other that are part of the shoulder joint. So up here, I'll go back up here so we got them all in order. So there's the sternoclavicular joint. So hopefully you'll realize that sterno refers to the sternum, and then clavicular refers to the clavicle. So that's that joint between the sternum and the clavicle. And there's a little picture of it here. So that little joint there where the clavicle is going to connect with the sternum at the manubrium, that's where you have one part of the shoulder joint. So that's one part of the shoulder joint. The other one is the acromion clavicular joint. So again, you break the words down. Acromial, remember, is the acromion process of the scapula. And then clavicular refers to the clavicle. So that area where the acromial process of the scapula connects with the end of the clavicle, the acromial end of the clavicle. So here's a picture from lab, I think, that shows these joints a little bit better than the ones in our textbook. So recall, this was our sternoclavicular joint here that we looked at, and then this is that acromial clavicular joint. So we got the acromial end of the clavicle and then the acromion process of our scapula there. So we got one here, one there, and then the third joint that's part of our shoulder joint is the one that we primarily think of. That's where the head of the humerus, so this is our humerus bone, so the head of the humerus, it fits into the little glenoid cavity of our scapula. There's like a little shallow fossa or depression here. So that head of the humerus connects with the glenoid cavity of our scapula bone. So they call that, because of those 2 structures, they call it glenohumeral joint. So that's the glenohumeral joint that's associated with our shoulder joint. So that was the third type. Oops, I'm on the wrong place here. Let me go back to our shoulder joint. There we go. So there's the glenohumeral joint. So those are the 3 joints that are making up our shoulder. So I'm going to slip to our objectives here, learning objectives. So we described the 3 different types of joints, so you should know those 3 and their names. And then the next objective is explain why the glenohumeral joint is relatively unstable. So the glenohumeral joint, if we'll go up here and look at this picture. The glenoid cavity, the reason that it's not real stable is the glenoid cavity that the head of the humerus kind of contacts and forms a joint with, it's pretty shallow. So really it's not so much the bony structures that are kind of forming this joint and making it strong and stable. It's more, you got more of the soft tissue structures like ligaments and muscles, tendons, those kind of things that are actually giving the glenohumeral joint that strength and stability. But since it's not the bones, since we have these bones that they're almost just kind of like sitting next to each other, they're not like interlocking like some of the joints we'll talk about in a little bit. There's just not as much stability because we don't have that bony interlocking bone surfaces causing a lot more stability. It's more soft tissue that's forming that stability. So because we don't have as much stability as other joints at this glenohumeral joint, we get more movement there though, which is what we want, is more range of motion in our upper limbs. So we're kind of trading off for more range of motion and movement. We have to kind of trade it off with stability. So in general, as joints become more stable, then their mobility or their range of motion decreases, but as those joints that have a lot less stability, they're a little bit more unstable, more likely to become dislocated, they're going to have a lot of greater range of motion. So it's kind of a trade-off. So there's good and bad when it comes to stability and mobility of joints. So the next thing we'll talk about is the joint dislocation. We usually talk about that with shoulder joints, since we do have, this is the joint with that's less stable than a lot of other joints in the body, so it's more likely to become dislocated. And so they call a dislocation, it's just any injury where the bones that are forming the joint or articulating, they separate. And again, it's pretty common in the shoulder because the shoulder is the way it's formed, the anatomy, there's more soft tissues, ligaments, muscles, tendons that are making that, kind of holding those bones in position, and not so much the bones themselves. So much more likely to have a injury at the glenohumeral joint and have it actually dislocate, where the bones actually come out of alignment or completely get separated. Now, when it comes to all the shoulder joints, so we have 3 of them. That one that's the sternoclavicular joint, that one is going to be the one that's the strongest. So it's going to be less likely to have a dislocation. But the other 2, especially the glenohumeral joints, can be dislocated. And so that is our definition for dislocation. And then realize that glenohumeral joints, and then second would be the acromioclavicular joints, are ones that are likely to become dislocated at the shoulder. And I got some pictures here so you can see what it looks like when they do become dislocated. All right. So I'm going to end this video, and then the next video we'll talk about our elbows and some other joints within the body.